Hi, I'm Kaiqiao, and today I want to talk about how to convert an electrical vehicle to a self-driving vehicle. First, I want to introduce the IGVC self-driving challenge, and then a drive-by-wire system we did for converting an electrical vehicle to a self-driving vehicle. Third, I want to introduce the software we are using. It's called ROS, Robot Operating System. IGVC Self-Driving Challenge stands for Intelligent Ground Vehicle Competition. It's organized by Auckland University in every summer in June. It has two different challenges. One is called Navigation Challenge and the other one is called Self-Driving Challenge. The Navigation Challenge is using a ground robot to follow the GPS waypoint. And during the pass, you have to stay in two lanes and avoid the object. We have several waypoints you have to reach one by one. This is my vehicle designed for navigation challenge. You see, we are using a GPS to receive the GPS signal and go each waypoint. And then using the camera is looking for lane lines. This camera can keep your robot in the two lines. And we have an e-stop. And also we have radars and lidars to avoid objects. Our robot is called Octagon. The self-driving challenge is totally different. It's using an electrical vehicle to pass several tasks. For example, this task is called stop and turn right. The vehicle is from here. You have to detect the stop line and then pass the stop line, turn right before the object. This is called long curve keeping. The vehicle should follow the long curve and then stop by the object. This challenge is called merge. First, you go straight and then merge to another curve. This is called stop by pedestrian. The vehicle should go forward and then stop by the pedestrian. This is the basic task. It's called stop by the object. And then the stop and turn left. The vehicle have to detect the stop sign and stop line and then turn left. This challenge is called parking out and parking in. The vehicle should parking from the parking lot and then parking back. This is our vehicle. So we convert this vehicle to a self-driving vehicle in 14 days and win the first place in the 27th IGVC competition. Here is a video. So here is the video I made for our competition. This is a first-person view. You can see there has the emergency stop in the vehicle, and then our vehicle is detecting the two lanes. This is the first challenge for the competition. You can see the blue shirt is George. So the judge is very nervous because we are running in the auto mode motion. We go straight and then detect the stop line and then turn right. stop by the object. You can see we have two different lighting systems on the top of the vehicle. One is for the self-driving mode, and the other one is for manual mode. This task is called pedestrian detection. The vehicle successfully detects the object. This is a parking in and parking lot. We have to parking inside the parking lot and then stop by the object. This is the detect the stop line and then turn left. This is a long curve. The vehicle should follow the long curve and then stop by the object.
Here we go! Finally! Thank you!
So let's talk about the detail about our work. I got a question for you. If you want to do this job, which part of the vehicle should be controlled? So because we have the basic requirement for the competition and basic function for the self-driving vehicle, so we have to control e-stop. So we have 4 different e-stop. There are 2 e-stop in the back. One is inside the vehicle and has 2 wireless e-stop. We have to control the steering system to control the vehicle turn right and turn left. We have to use a speed control to control the vehicle speed. Also, we have to use a forward and backward motion. We need a brake system for brake the vehicle immediately, and we also need a lamp to show other people what we are doing. Also, we should control a sensor system, which including camera, LiDAR, and radar for object detection. So we plan using our laptop to control our vehicle, but what is in between? What is the middleware to connect the vehicle with the laptop? The Arduinos. We are using 4 Arduinos to separate the whole system to 4 parts. The first part is called steering by wire subsystem. In this subsystem, one Arduino is sending commands to stepper motor driver and then control the stepper motor. As a feedback, we are using a distance measurement sensor to reading the exact angle our steering turned. The other subsystem is called throttle, brake by wire, and e-stop subsystem. In this subsystem, we're using one Arduino to control the front brake, rear brake, throttle, manual, control switch, and then 4 e-stops. The speed measurement system, we're using one Arduino to read the speed message directly from the vehicle motor. In the light-by-wire subsystem, we're using one Arduino to control different lamp, and the forward, reverse switch, and the safety light. For sensors, we are directly using computer connect with camera, LiDAR, and joystick. So I'll show some detail about our work. This is steering control subsystem. This one control the stepper motor, and then using a belt to connect the motor with the shelf, and using a wired potentiometer to reading the exactly angle we did. To read the exactly angle the motor turned. For ACC brake subsystem, we using a low-pass filter to passing our speed message to the H-bridge and then control the hydraulic liquid brake. And this is the vehicle backward safety light control subsystem. You see there are two different lights on the roof of the vehicle. So one is blinking for the auto mode, and the other one is always lighting when you manually control the vehicle. For the vehicle speed measurement, we using a Schmitt trigger filter to reading the raw data from the motor. Yeah, this is the steering control system. So you can see here, this is the stepper motor. We are using a belt connect with the shelf. Under the shelf, we are using a distance measurement. Put the wire on the shelf. So by this way, we can know exactly angle the steering turned. This is a very important feedback signal to control the vehicle. This is called throttle and brake subsystem. The Arduino sending PWM signal to two H-bridge. So one is control the front brake, and the other one is control the rear brake. The reason why we're using two brake because this can immediately stop the vehicle, but it cannot hold for a long time. After we immediately stop the vehicle, we are using the linear actuator to stop the vehicle for a long time. And then another PWM signal is sending to this filter to throttle signal. And then we have a 4 stop, the 3 stop on the vehicle, and there has a wireless stop. This is a lighting system. The relays to control the brake lamp and safety light, and also for the forward and reverse switch. If you want to do this, be careful these three wires. The switch is a 72 volt. It's very dangerous. So be careful about this. And the other one is called speed measurement subsystem. Because the raw data is not good for signal process, so we have to use a Schmitt trigger filter to change this wave to rectangle wave, and then reading the frequency from the vehicle. So this is a wireless control subsystem. We are using a joystick to control the vehicle manually. So you see the right joystick is control the vehicle forward and turn left and turn right. This is forward. If I push the joystick forward, the vehicle will go forward. And if I push the joystick left and right, you can see the steering is changing the angle. Okay, let's have a look again. If you push the joystick backward, the brake will turn on. This is my favorite picture. My two professors is sitting in the vehicle. This is Professor Casey, and this is Professor Iko from Japan. The reason why I very like it because we are in the manual mode and the joystick is on my hand. So that means I can control the vehicle. And two professors sitting in the vehicle, they can do nothing. So you see, they look happy, but they are very nervous. This is the demo for control the vehicle manually. It's like playing a game. I'm good at playing video games, so I'm good at control the vehicle. Yeah, I saved this vehicle. So this is a driver-wire sensor system. We are using different ranging sensor and camera to detect lane lines and objects. So first, we have a 3 subsystem LiDAR. It's looking for objects under the ground. And then this camera putting in the right side to looking for lines. And this LiDAR, Hukuyu 2D LiDAR, put in the front to looking for object. This is the driver-wire power system because we have a different voltage level on the vehicle system, so I made this power distribution. So we have input is 12 volt. Oh, by the way, the vehicle is 6 times 12 volts is 72 volts for the vehicle. And then we are using one separate battery to power for our driver-wire system. So the 12 volt will switch to 5 volt and 24 volt. This black thing is fuse box. You should put some fuse to protect your circuit. Because you're working on a high voltage system. So this is the detail for the power distribution. You can see the input is a 12 volt battery, and then the 24 volt is power for the wire potentiometer and step motor controller and step motor, and the 12 volt mainly is for the sensors, the subsystem LiDAR, Hukuyu LiDAR, Ethernet switch, radar, liquid motor actuator, safety light, and also power the computer. The 5 volt is mainly for 4 Arduinos and 2 cameras. This is the vehicle hardware setup. In the red picture, you can see our 4 Arduino is in the left side, and then here is another fuse box to protect our circuit. This is the motor driver. This is the power distribution board. This is the separate battery. The left picture shows I'm trying to solve a problem. Because one of my team members, he connected the vehicle ground to 72 volt. So suddenly the vehicle is disabled and then some magic smoke is coming out. So I'm very scared because the vehicle is shut down. So I'm trying to solve this problem. I look in the menu and I look in the motor controller menu. So I almost check every part in this vehicle, and then I found there's a one pin in the motor controller is disabled, it's short. So I made some solutions and make it work. I almost spent 3 days, day and night, to solve this small problem. If you want to do the same things for your electric vehicle, so be careful, don't short the vehicle. It will cause a lot of problem. Okay, the next part is called Robot Operating System. ROS is a very popular software in robotics. So ROS is not a real operating system. ROS is like a robotics middleware. The ROS provides service between system and low-level device. For example, sending a message from computer to Arduino. The beauty of the ROS is ROS can control different sensors at the same time and different sensors working separately. And also it's easy to add or delete sensors or subsystem. This is some ROS concept. So the ROS master is ROS Node Management. If you run the ROS master, so every node can find each other. And the node, what is node? Node is an independent program. It's running your code there. And the message is a specific data that transmitted over a topic. And service is the request and response channel of communication between different nodes. So you have from node 1 to node n, you have n nodes, and each one is running your program. And the message is talking to each other between the two nodes. And the topic is a publisher and subscriber channel of communication between different ROS nodes. What is publisher and subscriber? A node publish message to a topic is called publisher, and subscriber is subscribe message from a topic. For example, this is a small system. So your computer is connected with a camera. And in the camera node, it runs some camera drivers can receive data from camera. And then this camera node also publish the message to this message data message topic. This topic subscribed by this image processing node to do some image processing step. And this topic also subscribed by the image display node to display what is going on in the camera. So you can see this is a small subsystem for the camera. You can add more cameras to add more topic. You can add more sensors, like add more lidars and radars. It's very easy for ROS. And meanwhile, different sensors working separately. If you have two cameras and one of them is broken, it doesn't matter because you have another is working. This is some tools for ROS. This RBT Graph is a handy tool to visualize the current state of ROS node and topics. So you can see different topics sending message to nodes and then sending message to another topics. So this RBT graph, you can easily to see which node is connection to which node and which topic is subscribe or publish message to nodes. This is called ROS, is another ROS tool. So ROS is handy to visualize the current topic message. In other words, the ROS can see what robot can see. For example, this is my octagon robot for navigation challenge, and then it's using a Connect camera to looking for the object. The colorful point cloud is generated from the Connect, and the white point cloud is generated by the Fukuyu 2D LiDAR to mapping or to detect object. And there's also a tool called Gazebo. Gazebo is a simulation environment of the real world. So in the Gazebo, you can build a world. You can put a box near your robot or put another box near your robot. And your robot is seeing the real world. Your robot is detecting the white box and also the green box. If you don't want to buy a robot, and you can use the Gazebo to play in the simulation robot. In the last part, I want to introduce a Dataspeed drive-by-wire kit. Dataspeed is a self-driving company which made product for autonomous vehicle, and I'm currently working in this company. And this drive-by-wire kit can control vehicle brake, throttle, steering, and shifting. It's same as what we did in the HVAC competition, but this one is a real product for industrial vehicle. And some detail of the drive-by-wire kit. It has 32-bit microcomputer running C code and using CAN message to communicate with the vehicle, and also use the ROS to control the whole system. And this kit is using USB connect with the PC and ROS, and using CAN message to send a message and receive message from the vehicle. And some model is available for the Dataspeed drive-by-wire kit, like the MKZ and Ford Fusion or the Pacifica. Okay, thanks for you watching my video. I hope this video can help you to build your own drive-by-wire kit for your electrical vehicle. And if you have some questions, you can contact me, and I'm glad to help. Thank you.